Yeah, good morning. Are you happy to be in class today? We thank God for another day in physics class. So today we are talking about an interesting topic, and that is why I'm looking sportish, because we are talking about motion. Motion. I'm moving from here to here. The time I took off is definitely different the time I'm going to land there. So I have moved at a particular distance and at a particular time. So here we'll be talking about velocity time graph. That's what we are discussing today. And at the end of the class, I expect students to be able to draw a velocity time graph to understand what uniform velocity means as well as uniform acceleration. So let us start. What is uniform velocity? What is uniform acceleration? Now when you're talking about uniformity, you are referring to equality. Now velocity simply means what? Displacement over time. So when you're talking about uniform velocity, it has to do with what? The distance being equal to the time there. Now you are moving at a particular distance. So the rate at which you are increasing, you are moving rather, the rate at which you are moving with time is the velocity. So for your velocity to be uniform, the distance moved over the time must be what? Constant. As the distance increases, the time taken must also increase. So we have a uniform velocity. When we say uniform acceleration, that simply means we are moving at a particular velocity. At that rate, they must be equal. That is, the velocity increasing must also be accompanied by the what? The time increasing. So when your velocity as well as your time taken is also constant, then we say it is what? Uniform acceleration. When the velocity increases, the time also increases. When the velocity decreases, the time also decreases. So that is the uniformity there. So what is acceleration? What is retardation? Retardation can also be referred to as deceleration. You are moving at a particular acceleration. You are accelerating. From the English word accelerating, that means moving up. So the velocity increases with time. So you are increasing up. It will get to a point, it becomes uniform. It becomes what? Uniform. And later, you can as well decelerate. That means you what? Retard. It comes down. So the velocity there is coming down and the time taken. So now let's look at this one. Look at this illustration. We have our velocity time graph. That is velocity plotted against time. The velocity plotted against time. As the velocity increases, the time also what? Increases. Look at it. That is why we have our uniform acceleration. That is why we have uniform acceleration. But look at this place. The uniform retardation. The velocity drops. The velocity what? Drops here. So if you are told to calculate your acceleration, you are calculating the uniform acceleration based on this angle, triangle rather. This is the triangle for your uniform retardation. Uniform acceleration, while your uniform retardation is this triangle. So invariably, when you are constructing a velocity time graph, we are also looking for what? The acceleration. That's the first step, acceleration. And this simply means that body is starting from rest. That is the zero. The initial velocity is what? Zero. That is why the body is starting from rest. It started from rest here and moves up. Increase in velocity to increase in time. That is why it's moved up. Now maintains the uniform velocity. That is constant here. At that velocity, it's constant before it now drops or retarded. And this could also be referred to as deceleration. So this is just a simple illustration how a velocity time graph looks like. It's just a simple illustration. The velocity with time makes it a velocity time graph. Makes it a what? A velocity time graph. So you have your velocity to your